Thank you all. Okay, I can tell everyone's ready. Room quieted down. Thank you for coming to this session. My name is Jed Sundwall. I run the Global Open Data Program at AWS, and our mission is to expand access to data by staging it for analysis in the cloud. Today you're going to hear from two speakers, Daniel Manero Bernao, who's a solutions architect in Spain for AWS, and then Roope Tervo from the Finnish Meteorological Institute to talk about a collaboration that they've been doing with us to expand access to meteorological data on AWS. So I hope you enjoy this session. I'm really excited about this one. We're big fans of open data at AWS, particularly as governments are starting to produce really large volumes of data. The cloud provides a really powerful mechanism to make sure that as many people as possible can access that data and put it to work. And you're going to learn about that right now. So thank you very much for joining us. And welcome our speakers. Thanks.
So good afternoon. My name is Daniel, as you already know. And today I'm going to take you through this open data presentation, the first part. The second part will be handled by Roope. And thank you very much for taking the time to attend today's session. And let's start. So I think that the first question that you may have when coming into this session is why Amazon Web Services care about open data? And the answer is quite simple. We care because our customers care. So we see many of our commercial sector customers relying as much in high-quality open data as they do in our cloud platform. And this is especially true in some verticals, like, for example, transportation or aeronautics. We have a customer, like, for example, Digital Globe, that uses the OpenStreetMap public dataset extensively for some of the services. We see also that many of our public sector customers have a need to share their data with researcher communities, with the students, with entrepreneurs, and they're using the Amazon Web Service platform for that. One example is the UK Meteorological Office, which is sharing meteorological data from the forecast model on our platform. And in this context is where the Open Data Program kicks in. So the mission of the Open Data Program is to make more data available to more people, because we strongly believe that when more people access to data, more opportunities to extract value from it will appear. And we do it in several ways. One of the ways we do it is through our public dataset program. In our public dataset program, we host several high-quality open datasets, public datasets, and we make them available for free to anyone who wants to use them. We currently work with 3 different categories. The first one is Earth observation, with a focus on sustainability. And here you can find datasets about, for example, climate models, Earth imagery, or elevation models, for example. The second category we work with is lab science, with an emphasis on genomics. And here you can find, for example, the public dataset for the 3K Rice Genome Project. We host around genomic information of around 3,000 varieties of rice. The third category that we currently work is machine learning public datasets. And here you can find datasets that are good to train and to evaluate machine learning models. For example, here you can find the Amazon Bean image dataset that contains around 500,000 public images that you can use, for example, to train an image learning model. And why is it important to host these datasets and to make them available for free? So this is important because when you think about how traditional data acquisition works, first you may have all your data stored in tapes that needs to be restored into your data center. From there, you need to bring it to your servers, maybe network transfer, you transfer the ticks, I don't know. And then from your servers, your client needs to retrieve this information and needs to bring it back for the analysis. And normally, this is not a very straightforward process or a very quick process. On the other hand, if you think about how data is shared, normally it's shared in a format that is good for archiving, but it's not good for analysis yet. So quoting a book called Data Driven, as you can see on the slide, it says that around 80% of the work of a data science is around cleaning, structuring, and formatting the data. And that's a lot of work. And for us, this is something that we call undifferentiated heavy lifting. And differentiating heavy lifting, let me explain what it is. It's a term that we use, and it's the reasoning behind many of our services. Because we try to listen to our customer. We try to stay close to our customers, and we try to understand from them what is preventing them, what is blocking them for doing what they have to do, from doing their core activities. And we try to help in that. So if you think, for example, our compute services or our storage services, with a couple of clicks, you have virtually unlimited capabilities of storage and compute. The other alternative will be to go and buy your hardware, deploy your hardware, build your software on top, and that's something that really is a heavy lifting task. When you think about how data acquisition works in the cloud, actually there's no data acquisition. The data is already in the cloud, and a set of analysis tools are around the data that you can instantly use in order to extract value from the data and to build apps on top of that data. All on the same platform, all in the same place. So the users, the researchers, don't have to go and download the data from the repository, don't have to go and load it back to their compute capabilities or infrastructure. Everything is in the same place, everything is under the same platform. Some advantages of sharing your data in the cloud is, for example, that data can be accessed from anywhere in the world. So that allows you to really create a global community of users that will share information about your data, that will extract value about your data, that will share how they're doing with your data. Another advantage is, for example, that you will have a faster time to insight. It means that, as I said before, you have your data and you have the tools to analyze that data on the same place with a couple of clicks away. So researchers don't have to install the tools to extract value from the data. Everything is there in the same place. The third thing I will mention is that there will be a lower cost to research or lower cost to knowledge, because in some way you don't have to commit upfront for a given capacity. You don't have to buy software. You don't have to buy licenses. You don't have to buy hardware. You just pay for the tools and the time that you use them, and that's it. Once you finish the analysis, you stop paying. And the last thing is that, as you know, in Amazon Web Services, we're constantly innovating, creating new services, and we're very sure that will create new applications for your services, new tools to extract value from your data. Let me now talk a little bit about some of the Earth observation public data set that we're currently hosting, and the first one is going to be Landsat. Landsat is a public data set that contains Earth imagery, and it's a joint effort between the US Geological Survey and NASA. And currently we have a satellite Landsat 8 orbiting around the Earth. So we just don't go and host the data sets. We do something else, trying to make it easier for the developers, easier to use this public data set. So first thing we do is we go and archive the data. Second thing we do is we provide each band within each scene available independently. And then we do kind of an internal geotiling to make sure that users can access to the piece of data that they need instead of having to go to the whole set. And lastly, we provide new scenes available every day, normally within hours of production. So that really allows you to build a data pipeline between data creation, data analysis, and data value for your applications. An example of kind of applications you can build on top of the dataset hosted on Amazon Web Services is Landsat Tiler. Landsat Tiler is an application from Mapbox, and basically allows you to browse satellite imagery of the Earth coming from Landsat. And one thing to highlight here is that there is no server involved. There is no server serving these tiles. What it is the public dataset hosted in Amazon Web Services and a couple of Lambda functions. Lambda functions are our serverless compute that will dynamically generate the tiles. So you don't have a server running 24/7 waiting for requests to serve the tiles. The tiles are generated by Lambda only when they need to. And what is good about sharing the data in Amazon Web Services and in a format that is very easy for developers is that we save a lot of time to all of those developers. In this chart, for example, from a company called Development Seed, you can see in a 3 years time frame of a project, the time it took for them to analyze data from Landsat public dataset. When they started using the Amazon Web Service public dataset, the time it took for them to analyze this data was really minimized. As you can see here in the chart, it's really impactable. And they make the calculations, and they said that they save around 250 days just by using the public dataset hosted on Amazon Web Services. And we're talking about all these kind of massive scale datasets, a 3 years time frame project, that is really a lot of time. The second public data set I wanted to talk to you about is NextRad. NextRad is the next generation weather radar public data set, and it's been somehow a difficult data set to work with, mainly because of its size. It's around 270 terabytes of information. And again, we just don't go and host it. We do something else to make it more useful for developers. So one of the first things we do is that we maintain a constantly updated archive of the NextRad data. So we have the whole data from NextRad and also being constantly be updated with new data. But we also provide you with real data chunks. And something else, we provide you with some topics that you can subscribe to in order to get updated when new data is available. So for example, you can get update when new real data is available. So this allows you again to build a data analysis pipeline for your applications. And in fact, since NextRad is being shared in Amazon Web Services, its usage has been increased in 2.3. We know, for example, that a company called Climate Corporation has cut the analysis pipeline in around 2 weeks. We also know that another weather company has stopped storing their own version of the datasets, and they are freeing up that revenue, and they are using it for new initiatives, new projects, and so on. And the last Earth observation dataset that I wanted to talk to you today about is Sentinel-2. Sentinel-2 is an initiative from the European Space Agency. Again, it's a public dataset providing with Earth imagery. And Sentinel-2 is part of the Copernicus program and currently has 2 satellites orbiting around the Earth, Sentinel-2A and Sentinel-2B. And we have provided a grant to a Slovenian company called Synergize that to explore new ways in which this data can be shared on our platform. And in fact, they are doing the data ingest in our platform. Synergize has built tools like, for example, Sentinel Playground that would allow you to browse Sentinel imagery, allow you to combine bands in order to get more visualizations. And they also have built another tool called Sentinel Hub. Sentinel Hub, powered by Synergize again, is a tool that allows you to analyze and visualize with your own GIS tool or with the cloud GIS tool information from Sentinel, but also information from Landsat, from MODIS, from many satellites, and compare all those information. Another example is an Austrian company called EOX. So what EOX did is they crunched pixel by pixel around 300 terabytes of information using some homebrew software, using some open source tools, using some tools from Synergize, and they created a cloudlet atlas of Europe. And they did this with our platform, totally automated and almost inexpensively. And they are also sharing the results. You can see the details of the result of this analysis. They're sharing it in the following links that you can see on the slide today. So if you're interested in finding out more about our Earth observation public data set, I encourage you to go into our homepage. And because we really want people to use them, and we really want people to help us solve the current environmental challenge that we have. And we don't want people to be constrained because they don't have access to compute or storage capabilities. We're providing with credits to all of those interesting projects that you may have. So please go into our site and submit your project. And just to wrap up, I would like to share with you what we've learned over these years working with open data and different customers. And the first thing we learned is that time is precious. Sorry, this is generally speaking, time is precious, but especially when talking about this massive scale data sets, time is something that you cannot get back. And if you're thinking about sharing data, you really should do it in a way, in a format that is really useful for developers, that don't take a long time to clean up, to format, and an infrastructure that allows you not only to have the storage, but also have the analysis tools very close. And that's why we think that the cloud, especially Amazon Web Services Cloud, is a very good way to do it. The second thing that we learned is that copying data is not good. Well, it's bad, in fact. And why we think it's bad? First thing is because it obscures the provenance. You may download a copy of the dataset, you may work on some results, but if the original dataset is outdated, you never know if you're having the right results, you're working with the latest datasets, and that's not good. Also, it creates a lot of latency. This is not a small dataset, this is a big dataset, and it takes a lot of time to download it to your own storage system. And as we said before, time is precious. And third thing, it duplicates the storage. So you may have the public data set already storage in the cloud, and there's not really a need to go and incurring costs in storing yourself in your own premise. So we think that with Amazon Web Services, for example, you have your data set already hosted there. You don't need to duplicate the storage. You don't need to download it, and you can keep the true copy there. The third thing that we learned is that building software is already a hard enough task. So if you're planning to provide data to developers, and you provide it in a way that is too raw, that's, as we said before, that is in a format that is for archival but not for usability, or if you provide it in a format that is too refined, that, for example, takes custom APIs or a subset of data very, very cooked up, your user base is not going to increase a lot. Your user base is not going to be big. However, there's a balance in the middle in which if you use open standards, if you document your data, if you make your data reliable, your user base is really going to increase. And that takes me to the last point, which is that you should invest in your community. Because building high-quality open data is, as we said, a really hard task, and you should focus on making your data reliable, trustworthy, well-documented, and making a good set, and trust your community to take your data further. Trust your community to take your data to new places and expand on new applications and innovation from your data. And we think that with Amazon Web Services, your community can find the tools to do so. And with this, I hand over to Roope. I'm not sure if it works.
Thank you. Thank you, Daniel. And good afternoon from my side also. So my name is Roope Tervo. I come from Finnish Meteorological Institute, and I'm going to tell you about open source and open data and how we use AWS for distributing the data. Finnish government and Finnish Meteorological Institute has a strong open data initiative, and since 2013 FMI opened its data, and since 2016 it also started to open its software. And the goal is that by end of 2020 every software which can be opened used by FMI will be open source. Why? The world is changing, and role of national meteorological and hydrological services is also changing. And that caused us many challenges. To mention few, we need to ensure authoritative voice in warnings. We sure need more efficiency and agility in development and operations. And maybe most importantly, we need to ensure the impact of produced information. So, how can open source and open data help us? First, open data and open source software can boost the development because data can be used easily. Software can be developed together with partners, and it's easier to use existing software. Open data also lowers usability barriers and thus increase data usage. And as I already mentioned, collaboration is open and easy. Open source software, of course, prevents from vendor locks, and so it makes easier to use existing software. And it also eases long and burden negotiations when doing collaboration. If you find some good data or good software, you can evaluate it. If it's good, you can use it. And if you need to develop the software, you can just develop it and push the changes to the master. Or you can find some third party to develop the software for you. Open data increase access, okay. Maybe I need, now it's working. Now it's working. Open data also increase access to weather and climate data. And that's important because data is valuable only when it's used. There's no sense of making data if it's not used. And maximal coverage requires several different channels and services. And one organization can't handle them all, especially relatively small organizations like us. Now here, open data helps, but weather and climate data is quite complicated to handle. There are huge volumes, the complicated data formats, complex domain, and so on. And there, providing proper tools empowers third party to use the data correctly. And providing proper tools also ensure consistent information regardless of service provider. Open data and open source supports research. It provides easy and open methods to access the data, and also provide easy tools to process and analyze the data. It also makes science more repeatable when others can easily access the same data, and also the very same tools which are used for research. That can of course make research also more challenging, but that's all good. Open data also is a great tool to ease public-private partnership, and open source software and open data provides seamless access to weather and climate data for companies from multiple providers. So, who are our potential users? Basically anyone who will need this kind of information, but to name a few, there are other national meteorological services. We can do this work together with them. International agencies, also we can do these things together. And then there's other environmental agencies, research institutes, environmental companies, private developers, our clients, anyone who would need this kind of information. Now, more detailed words about our open data. As I mentioned, FMI opened its data in 2013. And back then, almost everything which FMI has property rights to open was opened. The data content in our open data portal is very vast. There are real-time observations, historical observations, weather forecasts, climatological data, both observations, scenarios, marine forecasts, marine observations, air quality information, and so on and so on. And the data is provided freely in machine-readable format. Quite recently, we launched also user interface to fetch old observations, but most of the data is only available via machine-readable API. And FMI Open Data API actually follows Inspire requirements, which means that we provide certain type of metadata of the data. We provide certain type of services, WFS, WMS, CSW. We provide the data in certain type of data models. And actually, we provide the data, the same data, in many different data models to achieve maximal client support. And these Inspire requirements are good because they are based on OGC and ISO standards, and thus we can achieve maximal interoperability. And it's also good because we need to follow Inspire requirements and we don't have to do the same work twice. So far we have done quite good. We have almost 12,000 users in our open data portal, and we get little over 830,000 data downloads per day, which means almost 10 requests every second. We are quite happy with that, but still we want to increase access to weather and climate data, because data is only valuable when it's used. Data is only valuable when it reaches relevant audience and it can be used. And maximal coverage requires several different channels and services. And thus, FMI joined AWS public datasets as well. So that means that part of our open data is also provided in AWS S3. This is a 2-year pilot. It started in May 2017, and in the first stage, there are Hirlam weather forecast model, surface and pressure levels available in the S3. And our objective is to increase the utility and effective use of that data, and of course also support public-private partnership. Now this data can be, it's good for anyone who needs this information, but from S3 it's especially convenient for users who need the whole model data. For example, for post-processing or running some other models or generating map visualizations or so on. The data content is the same in FMI Open Data Portal and in Amazon S3. It's weather forecast model covering Europe with 7.5 kilometers grid resolution. The forecast is 2 days ahead with 1 hour time step, and it updates 4 times a day. It's one model output is roughly roughly 20 gigabytes large, and it always obsoletes previous one. It's also notable that archive of old weather model outputs are kept during the pilot, so you can fetch also old model outputs from the S3. That one you can't do from FMI Open Data Portal. So you can access the data through packets. You can browse packet contents with your web browser, and there are also simple notification service topics available so that you can subscribe them, and then you get a notification whenever new data is available. If you are interested in details, please see the documentation here. So, the pilot has been going on for 1 year now, practically. How well has it succeeded? Before showing actual figures, I want to give you some context. This chart here shows how data requests are divided between different data models in FMI Open Data Portal. Because as I mentioned, we provide the same data in different data models to achieve maximal interoperability for all kinds of clients and use cases. And these 3 columns on the right side stands for different kind of point data requests. And this left column, left invisible column, stands for grid data requests, which are provided in binary formats for whole model data output, 20 gigabytes. So you can see that for most users, we interpolate the data to the location of their interest and provide only point data time series. But there are still almost 50,000 grid data requests during 1 month. So it's a significant amount of requests for grid data also. And now this chart shows how binary Hirlam requests, grid data requests, are divided between FMI Open Data Portal and Amazon S3 after 11 months. This is for 1 month, from 1 month. Blue columns stands for actual requests, so S3 gets lots of more requests, but story is not so simple. because the data is divided in S3 so that different parameters, like for example temperature or precipitation or so on, are in different files. And in order to download everything, user needs several requests to download the whole model. But from FMI Open Data Portal, user can select the feature of interest, parameters, times, and area, and download everything with one request. And now, if we assume that every S3 users would download everything, we can compare the popularity of these two channels. And the comparison results are in red columns. And from there, we can see that Amazon S3 is a little over twice as popular as FMI Open Data Portal after 1 year. Anyway, daily requests in Amazon S3 varies a lot. At the moment, we get from 6,000 to 46,000 downloads per day, which would roughly mean from 200 to 300 users who fetch whole data operatively. I think this kind of variation is quite understandable because this is a pilot and it's been going on only for 1 year. So people are developing things, they are piloting things and experimenting things. But we still get quite good baseline, and we can see that S3 is very popular channel, more popular channel than FMI Open Data Portal for binary requests. And so we can see from our point of view that this pilot has been very successful, and our users really like this S3 more than our own Open Data Portal. But point requests interpolated to some certain point are by far the most popular type of requests. To give you one concrete example how this data can be used, I will tell you about a Finnish company called Clean Heat. Clean Heat is a software solution for optimized heating in centrally heated buildings. Clean Heat generates a building-specific demand forecast a few days into the future, and thus optimally adjust heating power at all times based on that generated model, forecast model. And that forecast model uses user behavior information, building thermodynamic properties, forecasted temperature, forecasted radiation, and indoor temperature to generate that model. And the goal of that model is to keep a stable indoor temperature with the least energy possible. And in order to do that, Clean Heat needs detailed weather forecasts for several areas in Europe. And they use FMI Hirlama weather forecast model for that. And as they are doing their processing also in AWS, they have found very convenient to use also Hirlam weather model from AWS S3 to achieve this goal. And here's everything. Thank you.
For a very, very interesting presentation. Not only that, but you've also got us back on time, which is even better. But we do have a few moments for questions if anybody wants to ask a question. Judd is also here and Daniela as well, so feel free. I'll pass the mic around and you know, the floor is open.
This one.
I have a non-technical question on how do you commercialize this kind of open data? How do you build a business model around this? Is this something once like you commercialize this in your applications, you need to pay to the FMI, or how does this work?
Okay. The FMI is a government institute, and our main goal is to provide safety and fluency for the society. So we are succeeded when bad weather doesn't distribute the society too much. And from that point of view, it's most important for us that this data and this information is utilized correctly.
And I'll just add to that. It's a really important question that a lot of people are still trying to figure out, and have been trying to figure out for a long time, which is that government organizations, they invest a ton of money to produce data products. A lot of them are obligated by law to just make those freely available at no cost. But the reality is that distributing data, especially when you're talking about terabytes of data or even petabytes of data, can be expensive. Somebody needs to pay for those costs, right? And it's TBD. You know, I don't think anybody's really figured out the right answer yet. One of the reasons we have the public data sets program at AWS is so that we can experiment in collaboration with our customers to figure out what would these things really cost? Like what are the real expenses, and based on actual usage information and real data, we can make better decisions about what the business models would be. The other thing that I want to emphasize though here is that when data is accessed within AWS, especially if it's being accessed within the same region, so if you have data in an S3 bucket and then an EC2 instance or some other compute resources in that same region is accessing the data, we do not charge data transfer for that. So when you stage data for analysis in the cloud, that data can be used and be put to work at a much, much lower cost than traditional methods which encourage download. So that's all.
Hi. Yeah. I have a question that is similar to what the previous person was asking. Does Amazon, or do you have any tools that you use to guard against bill shocks? Let's say that you become the victim of your own open data, that something becomes really popular. What happens? Do you have any tools that you use to avoid getting a really high unexpected cost at one point? Aside the fact that there's no charge within the Amazon network, but what if?
So yeah, there are a lot of ways to go about it. One thing that we do deliberately with the public data sets program, so for instance with the data that we host in collaboration with FMI, is the bucket's just wide open, right? And we do that intentionally so we can see like, when do these shocks ever actually occur, and what do they look like when they do happen? They do happen. It happens sometimes. Now, architecturally, I would never recommend that people put terabytes of data in a bucket and then leave it wide open, if you know, unless you're very aware and able to absorb those shocks, which we're able to do because it's an experimental project. There are a lot of ways to do this. So number one, S3 has a feature, it's very cool, called Requester Pays, and it's a checkbox. So when you create an S3 bucket, you can say, this is a Requester Pays bucket. You can make it open, but what it requires is that if anybody makes a request from that bucket, they have to say, I want this data from this bucket, and I'm going to pay the request costs. So that prevents against shocks, because whoever would shock you would shock themselves, to use that metaphor, right? The other thing that you can do, though, is you can make data available in S3, again, in a Requester Pays bucket, and then you can use services like CloudFront or AWS WAF, which is like our firewall product, that can help mitigate and smooth out those kinds of demand costs.
Okay, very good. Any more questions from the floor? No? Okay, well, thank you very much again to our speakers, and if I can ask you just to take a few moments to give feedback to our speakers through the app. It'll only take a few moments. We do value your feedback, and it helps us to better formulate these sessions going forward. So thank you very much for your attention. We have about a 20-25 minute break now, and with coffee, and would welcome you all back to the last session starting in about 25 minutes. So thank you very much.
Thank you.